Okay, here we have another piecewise function, the one I'm circling in blue, and we need to evaluate all of these things, a few limits as well as the f of 2 and f of 4. So how do we get started? What I'll do, again, is that I will graph this, and but it can, most things you can actually figure out algebraically also, so I'll do both for everyone. So starting with the graphing. So here we have y equals 2x plus 2 when x is smaller than 2. So x equals 2 is right here. So when x is smaller than 2, so to the left of this, that's what's going to happen, which is the 2x plus 2. What does that mean? And what does this look like? Well, it has a y-intercept of 2, right? And a slope of 2. It's just a straight line. So slope of 2 goes over 1 up 2. So I'm starting here at the y-intercept of y equals 2, right? Then over 1 up 2 because of the slope being 2 also. And one important detail is that we have x is smaller than 2 but not equal to. Okay, there's no equal to sign here, which means that at the point when x is 2, there's just going to be an open dot like that. And of course, this is just straight line. Wow, that doesn't look straight at all, does it? Terrible. Okay. That's a bit better. Hopefully you find it acceptable. Alright. Then we have x is greater than or equal to 2. So to the right of 2, we have x plus 1. And what does that mean? Now, that's again just a straight line with the y-intercept at 1 over here. But it's just going to start, I'm going to graph it over here first so that it makes sense. And then I'll consider the fact that it's just going to happen when x is greater than or equal to 2. So the y-intercept is 1 and the slope is 1. So we start here, go over 1 up 1, over 1 up 1, over 1 up 1, over 1 up 1. So a line going this way. But one detail, it starts only here at x equals 2. And why did I color in that dot there? Well, it's filled in because its x is greater than or equal to 2. Look at that. So that is our little function that we have. So let's jump into the limits. We want to find the limit as x approaches negative 2. No, sorry. That's not what it means. My mind is elsewhere today. I don't know what's going on. It's lack of sleep. When x approaches 2 from the left, that's what the little minus there does. We want to figure out as x approaches 2 from the left. What does that mean? Well, here's the 2. And as we approach it from the left, we get closer and closer to this value right here, which is, let's see, 1, 2, 3, 4, 5, 6. That's it. How could we figure this out algebraically? Well, because we were coming from the left, as x approaches 2 from the left, we must take the 2x plus 2, because when x is smaller than 2, that's what we're looking at right here. So we plug in the 2 into the x here. There's going to be a lot of 2's, so it's going to be 2 times 2 plus 2. So 2 times 2, 4 plus 2, 6. And now the next one will be, how can we find the limit as x approaching 2 from the right? So then if we want to do it algebraically, we're going to take this portion right here and plug in the 2. So it'll be 2 plus 1, 3. Because when x is greater than or equal to 2, if you approach the approach x from the right, that's where it's going to be. And what does that look like on the graph? You're coming over here. You have like 3, you have 2.5, you have 2.1, and you approach positive 3. Great. Now, what about the limit as x approaches just 2? It doesn't exist. And why does it not exist? Because the limit coming from the left and the limit coming from the right are not the same. That means that the actual limit as x approaches 2 just doesn't exist. Great. Then how about limit as x approaches 4 from the left? Now we got 4 right here. That's going to be a piece of cake. All we need to do is just plug in the 4. If we were doing algebraically, we would just take this portion, of course, because that's when x is great. Oh, this is becoming a mess, eh? Too bad. When x is greater than or equal to 2, we have the x plus 1. So you can just plug in the 4 right there to get 5. And that's it. It will be no different for the limit as x approaches 4 from the right. It will also be 5. So as we approach 4 from the right, we get right there at 5. Great. Now what about the limit as x approaches 4? Does that exist? It does, because these guys are the same. And they're both 5, so this must be 5 also. Fantastic. Now, what about f of 2? How can we figure that out? Well, when x is 2, the filled in dot here is right there, which corresponds to y equals 3. Right? And I need to, if I were to do it algebraically, I would pick the x plus 1. Because here it says x is greater than or equal to 2. Right, so I need to use the x plus 1. So I plug in the 2 right here, 2 plus 1, 3. Great. What about f of 4? We're also going to use the same, because 4 is bigger than 2. So 4 is bigger than 2, so great. We plug the 4 in here, 4 plus 1, 5. Fantastic. So that's it. Hopefully this made good sense. Although I was half asleep at some points in the video. Sorry about that. And yeah, just try a few more questions. Good luck.